Great. Thanks, everyone. Thank you for attending today. Our session today is going to be on enabling R on Hadoop. And my name is Paul Cotting. I'm a solutions engineer for Hortonworks. And with me is Ravi Mojela.
Hi, yes, I'm Ravi Mojela. I work as a systems architect, mostly focusing on third-party tool integration with Hortonworks.
Great. And I'm coming from you guys from Minneapolis. And the reason that Ravi and I want to talk to you all today about this specific topic is because kind of our role within Hortonworks is twofold, right? So I'm kind of on the field side, helping customers understand Hadoop, helping customers understand how technologies can integrate with Hadoop. And Ravi is kind of on the back end as far as doing those implementations. So a very common set of questions that we usually get is how do we actually use R on Hadoop? What are some of the options? How do I integrate? We see a lot of different customers that they're either experienced with R or they're experienced with Hadoop, but they don't really understand how to kind of marry the two together, right? And so our goal for today is to help you understand not so much on how to use R or how to use Hadoop, but really how to put them together. What are some of the options that we have? What are some of the open source utilities that we have to actually get a cohesive relationship going between those two components, right? So the agenda for today, we're going to talk about a brief history of R as a language and as a framework. We'll talk about how R is typically used or how we see people using it in the field. And then we'll finally talk about how we can actually use those two together. So how do we plug R into Hadoop, be able to take advantage of the kind of the best of both worlds between the two. And then we'll cover topics about how do you actually get started. I think that's one of the common things that people are looking for is how do we actually get traction? How do we get some of these things installed so we can actually start playing with this technology, playing with them together. So that's our agenda for today. Just some housekeeping stuff. I'd really encourage you guys, if you have questions, please use those mics. This is being recorded, so otherwise no one's going to be able to hear you guys, and we probably won't be able to hear you either. So please use the mics. Definitely like to keep it as interactive as possible. So if you have a question, let us know. We'll do our best to answer. If there's anything that we can't answer, we can follow up with you guys after the show. Okay? Okay. Cool. So we'll start quick with a brief history of R. R in and of itself is an implementation of the S language. So it's kind of important to look at the history of each language as you use it, because I think sometimes when you get frustrated with maybe some intricacies of the language, it's helpful to understand why, where it came from, what were the goals of the initial project. So if we look at S, the history there, it was created in 1976 at Bell Labs. And the first kind of iteration of that specific language was a set of Fortran libraries to do statistical analysis to help with the stats work that they were doing there at Bell. So later on, it was rewritten in C. That's kind of the V3 iteration of the language. And then in the major kind of additions to that were the statistical modeling capabilities, some of those things that we can take advantage of today in R. So SV4 was in 1998. That is kind of the foundation, forms the foundation of S as it's known today. After 98, it went through a number of different companies licensing the technology, those companies getting acquired by other companies. Now it's owned by TIBCO. So that's S at a very high level. From the R perspective, R was created in 1991. And by 1997, it was released as or I shouldn't say released, it was started as a GPL project led by a core group of individuals, some of those being some of the initial creators of S, right? So first release of R was in 2000. Now, as of last month, we're at R version 3. So now we'll talk a little bit about what are some of the typical usages that we see with our customers using R. So R in and of itself is an interpreted language. There's a vast array of different modules for doing a lot of different statistical analyses. The great thing about this language is a lot of people are using the open source implementation, and as such, it's very easy to get started. You can download it. They have a whole set of modules through CRAN that allow you to do visualizations, advanced analytics, advanced integrations with other technologies. And so the kind of the barrier of entry to getting into this language with at least being able to start rolling quickly is pretty low, right? Some of the uses that we see people using those modules in the language are definitely for interactive data analysis around statistics. So it could be modeling, it could be regression, classification, a lot of the things that you guys are probably doing today with R, right? What we're really trying to focus on now is how can we take some of those capabilities that R has and take it beyond just sample sets of data or small data sets that you might be using today for your statistical modeling? And how can you actually plug it into Hadoop to take advantage of the vast amounts of data that you've collected in your Hadoop environment, as well as taking advantage of some of the parallel processing capabilities of Hadoop? So what do those really look like, right? How can we plug those two things together? So if we look at Hadoop in general, this is basically kind of a typical Hadoop deployment. We have our data integration services. So this could be Flume, Scoop for data ingest. It could be data processing languages such as Pig, Hive. It could be data service access such as HBase, and just core Hadoop components as RHDFS and MapReduce. These are the core pieces of tech that our customers typically deploy. And what we'll be looking at today is what are those specific components that we can integrate with R, and what are the specific libraries that are available for us to make that happen. So looking at the specific modules that we have available to us today, the primary integration points are with the highlighted components below. So we have Hive, HBase, MapReduce, and HDFS. So the different components will integrate at those different layers, and they'll have different kind of focus areas, right? So those components integrating with Hive are more focused towards SQL type analytics. Those components focusing on MapReduce and HDFS are large data transfer and parallel processing. So what we're going to do is take a look at a number of the different options that we've seen specific customers use. And we'll talk about the focus of that specific project, how easy it is to actually integrate into your environment or into Hadoop. We'll talk about some of the benefits and limitations that we've seen, and just help you guys get a kind of a better understanding for what are those modules that are out there, what do they do, and start that process rolling as you're thinking about how you can integrate the two components together, right? So the diagram here on your right really kind of focuses on the kind of tightness of coupling or the tightness of integration between these specific projects and the core Hadoop. So the ones that we're going to focus on today are RODBC, RHDFS, Hive, and the Hadoop components. So with that, I'll turn it over to Ravi, and he's going to go through each of those components.
Thanks, Paul. Yeah. So I'll start with the RHDFS and RODBC connectivity to data that you have on. Thank you.
Yep.
Thanks. Yeah, so I'll first focus on RODBC and RHDFS.
Oh, is that better? Here, I'll adjust it.
Can you hear me?
Yeah. Let's do that. That better? Better?
So, okay. I'll start with our ODBC and JDBC connectivity first, which is a way to, it's the most lightweight way to access data in your Hadoop cluster through ODBC and JDBC drivers.
I guess still having trouble hearing. Okay, it's not working. Can you guys use this mic? Back in the back? Can we activate this guy?
All right, so
Is that better?
integration with the integration is what I'm going to start with. So all you need on the client side to connect to a Hive on Hadoop cluster is just the ODBC driver or JDBC libraries that you have on the client. And even on the connectivity side, they can be outside your Hadoop cluster on a different network. All they would need is one connectivity to a port, which is 10,000. So I'll go through the benefits now. The key benefit is that most of the customers that we go to, they already have some R scripts, and they have data in a relational data store, and now want to use or migrate their data with the growth of data into Hadoop. So the easiest part is migrating these scripts when we use our ODBC or JDBC, because the scripts itself will look the same. The data itself, like instead of a SQL, now we are doing a HQL access to the data, which is not much different. So that's a major benefit that we see, where whatever whatever scripts they have, we can quickly move them to using data in Hive. And as we mentioned earlier, there's nothing required on the client itself, no Hadoop libraries, just the ODBC driver or the JDBC libraries. Coming to the limitations of this approach, one is all parallelism that you have is in Hive. So say you have R scripts, you have some data, so you are issuing some queries. So whatever parallelism that takes place is at the Hadoop level or Hive level. And once it comes back, when you are working on your result set, there's no parallelism involved there. So it stops at that level. And the result set size itself will be limited by the machine where you have the R installed or the R client. So there is a limitation here. You won't get the whole data set from there and start accessing. You will do some aggregation, do a smaller result set, bring it into your R client and start working from there.
Yeah, I think one of the things to stress too here with this specific approach, or at least one of the ways that we see people using this, as Ravi had mentioned, is conversion of R scripts. A lot of the people we're working with are using maybe MySQL or other CRAN packages to access those RDBMSs. They want to move that data into Hive with not a lot of impedance, right? They just want to be able to quickly modify their scripts without modifying a lot of code. And this is a great place to get started because it's lighter weight on the client, as he had mentioned.
Yeah, this is the deployment consideration. As I said, so all you would need is access through firewall for a specific port where you have your Hive server installed. So that HS there is the Hive server. And you have other stuff on the Hadoop cluster, but your access is only through the Hive server. Yeah, the next library that we deal with is RHive. It has an interesting way of connecting with or connecting with your data. One is the HDFS part. So it can access your Hive data and directly issue commands to HDFS. So on the integration is, it requires the Hadoop libraries, obviously, since it's a DFS client that is there on the machine where you have RHive, and obviously the configuration files there. So the way it connects to HDFS is through a Java DFS client. So the key dependency here on the R side is RJava. You need to have the RJava package installed. And how it connects to the Hive is through the Hive server. It doesn't yet support Hive server 2 as far as we know. You can issue some of these lapply and rapply functions on this, but what internally it does is converts that into HQL scripts and executes on your cluster. So yeah, benefits here, if you see on the RODBC side, we stopped at the Hive layer, and everything else, all your algorithms you do after on the result set is on a single machine. So since in this case it's doing internal conversion to HQL, it creates if required some temporary tables to work around. So all the parallel power of your Hadoop cluster can be leveraged here. On the limitation side, can you go back? Yeah, it's currently supported only with Hive server, not with Hive server 2. So some of the security enhancements that are done on Hive server 2, right now we haven't seen anything that work being done on that. Yeah. So this is the deployment that we typically see. Now the edge node has to be on the cluster because your DFS client, the way that it accesses data, it has to talk to all your data nodes. Because of that, you'll need to put it either as an edge node with a big set of ports open, or move it as part of your cluster. Yeah, the next
thing, the next library that we will focus is on RHadoop. It's actually a project now which is split into 3 different libraries. One is RMR2, RHDFS, and RHbase. So again, the focus here is on tight integration with all the Hadoop components. And the key benefit here is it can access or it can work on your big data set. So you need not go and do sampling of data and then or work on a smaller subset of data. You could be able to use the run your algorithms on your full data set instead of a sample data set. Yeah, this is the architecture of RHadoop. So as I said, there are 3 components. One is RHDFS, second is RMR, and the third is RHbase. The way RHDFS interacts with your Hadoop HDFS cluster is through, again, a DFS client. So even here, there's a dependency with RJava. The second library is RMR2. This is the key library that actually issues the MapReduce jobs to your cluster. And so there is a map and reduce which can be written in R. And the MapReduce itself will use streaming framework, the Hadoop streaming framework, to talk to R installed on each of the nodes. The third one is RHbase. This will use a HBase Thrift gateway to talk to HBase. Again, with the Thrift gateway, it's not a HBase client, but the Thrift is a C++ or there's a support for multiple languages on the Thrift layer. The problem or advantage of one of this approach is that the data goes through one node. So if you are considering your deployment architecture, all you need is open port to that Thrift client instead of to all your region servers on your cluster. Okay, so starting with RHDFS, it's basically a read and write access to your HDFS cluster. Internally, it uses a RJava to connect using the RHDFS client. The latest install is, or the latest release is 1.0.6, which is released last week, and it adds support for Windows as well, using Hortonworks Data Platform. Okay, so I'll go to, I just listed out some of the common command line things that you use using the HDFS command line and the RHDFS equivalent here. So if you want to do a ls, it's a hdfs.ls. Create a directory will be, there's an equivalent of mkdir. Then there's a fs put. So here what we are getting is loading it into a data frame called local data and then putting that data frame into Hadoop. Similarly, there's a get, and if the ls itself returns all the data as a data frame, so all the permissions that you get are all in a data frame on R. Same thing with an RM, there's a delete with the file name. Yeah, RHbase. As I said, it uses the Thrift API to connect. So what we generally see is there is a development gap between the HBase client and the Thrift API or the Thrift client. Sometimes whatever is developed on the HBase client doesn't get reflected immediately on the Thrift client. So that is a bit of a disadvantage here, but there are always a lot of third-party people who add all the IDLs and update the Thrift API. So you can create a table, you can modify a table, add data, scan, get, you can do all that in our HBase. And some of the command line examples are those that you can see. Scan.ex is a conditional scan on the table, while scan itself is a full scan of the table. RMR2 is actually the key library in the RHadoop framework. This is the part that uses Hadoop streaming extensively. So it gives you the, if you look at all these components, this is one component which gives you the ability to write parallel algorithms using the Hadoop framework. Can you go back? Oh, yeah, sorry. Yeah. Thanks. Yeah, so one of the API is MapReduce, which takes the input, the output, a map, and reduce. So here the map itself is a R function, same thing with reduce, and the input and output are the location of your HDFS files.
The MapReduce 2, does that refer to yarn, or is that a R thing?
No. RMR2 only works with MapReduce, not the MapReduce 2. The reason why there was a change on the name from RMR to RMR2 was some of the APIs were removed, so they had a version change there. But right now it doesn't support yarn. Yeah, right now all the access is support is only for MapReduce.
It is, yeah. So we were actually talking to Antonio. He kind of manages these libraries yesterday, and we'll be working with him to add yarn support. Yep. But it's something that's in progress, but not available yet. Mm-hmm.
What's your timeline for that?
I'm not sure of the timeline right now, but I can check on that for you. Yep.
Okay, so and again, the latest version that was released last week was 2.2.1, which again adds support for Windows using the HTTP. Okay, this is one of the sample code. As we start with a word count on most Hadoop samples. So what you see there at first is a map function. So where it's actually splitting the lines based on a pattern, and then there is a reducer which is doing a count on a key and values. And then you have a MapReduce which takes the input, the output. In this case, there's a input format. Then there is a map, there's a reduce, and after that you can send a set of parameters. In this case, there's a param that says that combiner is true. So we'll next go to an example where there's an algorithm that or a R function, and how do you code the same thing using RMR. So this is a binomial that returns a list, and then you are doing an apply on that, trying to find the number of occurrences of each value in the binomial. So on the Hadoop side, what we have at the first is a 2DFS. Since our Hadoop cluster, this is a MapReduce job, and the data needs to be accessible to the cluster, each node on the cluster. We are putting the data into the cluster using 2DFS. But in general, you might have Scoop or Flume putting the data into DFS. HDFS, and then you use a from DFS, which is reading the data from DFS. So here we see a MapReduce. Again, the input, you don't have an output here. The output itself is being directed out into a list using the from DFS. Then there's a data frame to from DFS. and then there's a reduce function here, which is actually finding the length of each collection. Coming to the deployment considerations of our RMR packages or our Hadoop packages, it has to be on one of the edge node, since it has a DFS client which needs to talk to all your data nodes. Then it talks to name node again through the DFS, and then the job tracker. I'm sorry, 1 minute. And once you have going into the architecture, when you have a map file, so the R stream, it creates a R streaming code, and then it executes on each of the nodes. So in this case, you'll need R installed on all your data nodes. Coming to the limitations of this, one thing, you'll need R on all your task tracker nodes. It's now just not on a single node where you are working off. Then it doesn't automatically parallelize your algorithms, or even the goal of the project is not parallelizing your existing packages, any of your R packages. All it gives you is the ability to write your own functions and use the power of parallelism of your Hadoop cluster. Then this is one key limitation where when you do a slot and memory configuration on each node on your cluster, if you see, we leave some space for the OS and then use the rest for MapReduce. But in this case, you need to leave some space for R, which is outside your scheduler, because you cannot really schedule what R is doing. So there's an OS layer, there's a consideration for leaving CPU cycles and memory for R, and then you need to use the rest of the space on your configuration.
Yep, and so I think one of the key considerations as we've gone through a number of these different libraries really is when it comes to looking at your specific needs as far as what you're doing with R, what you're doing with Hadoop today, how can you help kind of make some decisions on what specific module to use. There's a number of different considerations, one of those being what are your existing R scripts doing, right? What does the analyst workstation look like? Just how much ease is there to actually install some more heavy client libraries? If they're kind of used to SQL, used to doing that type of analysis, the RHDFS package is usually kind of the quickest way to get them started. If they're looking at going beyond their existing sample sets and trying to identify how can they program in a lot of the parallelism, then getting as deep as they can with things like RMR2 is usually the best way to start. But I think what we typically see with people running into some roadblocks is just helping the people that are doing the analysis right now, the R work right now, A, understand MapReduce, and B, understand how they can kind of map their specific problems into MapReduce paradigm, right? So as you guys are kind of going out there looking at talking to your specific business folks that are doing this analysis, some of the things to consider are just, what is their aptitude for using SQL, what is their aptitude for and making that kind of cost-benefit analysis, right? If we look at how we actually kind of get started with this, there's a couple different options that we have. One of the things that we always like to tell people is about our sandbox. As we looked at helping people get started with Hadoop very quickly, especially with using some of these technologies, having something on your desktop where you can start playing around with these different products, understand their limitations, understand their constraints for yourself is very helpful. So we encourage you to download the sandbox. And also, there's just kind of the process of how do you actually get all this stuff installed, right? The installation process that we kind of focused on here is focused on RHadoop. That's usually one of the more common packages that we see people using. Like Ravi had said, one of the limitations is that because we're using R streaming for this, we have to install R on every single node in the cluster. Every single package or CRAN package that you want to take advantage of within your MapReduce code also has to be installed in the cluster. So depending on your cluster size, sometimes that can be a little bit of a constraint or an issue for people. We'll be producing some documentation and a white paper as well as a kind of a blog post that goes through more step-by-step type details to help you understand A, what's necessary for RHadoop on your cluster, B, how can you actually script that. But these are just kind of a list of some of the dependent packages that we have for RHadoop today. So once those are installed, you can download and install RHadoop, the specific packages you want, directly from GitHub. So with that, we can kind of go into some Q&A. If you guys have any questions, we'd love to hear them. Anybody? Sure.
A couple slides ago, you talked about the memory issues, R slot management issues with R. So, as you know, R is a notorious memory hog, and we're having a lot of trouble with our Hadoop in production because of the memory issues you just talked about. So do you have any best practices? How are people addressing that? How do we get beyond that?
Sure.
That's a real issue for us.
Yeah, one way is to, so we have typical recommendations on number of slots you would need, amount of memory that you would use, like things like 1.5 times your CPU cycles left for MapReduce for it to be used. So what we try to do is reduce this in case we are using R. So say our general recommendation is something like 1.5 times your CPU cycles. That's the number of total number of slots per node. So in this case, we go with 1 instead of 1.5. Similarly, on the RAM side or the memory side, we try to limit the amount of memory on each JVM. So there's room left for R.
Any other questions?
Sorry, I know that with Hive you can run R on each of the nodes in the cluster and have it stream the data through R on each of the nodes. How is your implementation different from that in terms of performance and, well, the difficulty of programming, like doing SQL and embedding an R command compared to like doing all R programming? Could you please?
Sure. Yeah, no, it's a good question. So it's basically embedding R and using Hadoop streaming within an HQL statement versus using something like RMR2, for example. Yep. I think, from a difficulty perspective, it's hard to say. I can't really comment on that. I think usually where we see people going is just kind of one or the other. They're not mixing as much. That at least I've seen personally. You just kind of you're either going to write HQL or use something like RHive, which will using some of the apply functions to generate HQL for you, or it's going to be just straight R using something like RMR, RMR2. Yep. From a performance perspective, I'm not sure. I'm sorry, I can't say. Yeah.
Yeah, they're actually like on the performance side, we take care of things like one key thing is trying to reduce the number of data frames that comes out, which we do by reducing the the key set. So that's one key constraint. So if you have a big key set, you'll generally end up with performance issues. So if your algorithm can support, you can do a modulo on the key set and reducing the key set.
I know within RMR2, there's been a lot of additional support for vectorization, and I think if you compare RMR to RMR2, I know a lot more work has been focused on simplifying the API, as well as steering people more towards the performant option than the easy and non-performant option. Any questions, sir?
Yes, I'm curious if you know if the RHDFS package can actually access HAR files, index subfiles within there?
I'm not sure. That's a good question. I mean, it uses the Java DFS client, so I would assume it would be able to, but I haven't ran into that situation where I've had to pull information out of a HAR through RHDFS.
And can you comment about the interesting challenge of managing and maintaining the dependency graph of R? It's very much like Perl in that everything depends on a million sub-packages, and deploying that into a cluster is a non-trivial thing to do. Although you just put it on one slide, it's, especially when you have multiple versions of R and multiple packages and all those versions, that's obviously pretty painful of a task in and of itself. If you can comment on your experience with that?
Yeah, definitely. I think usually what we try to do with clients is we try to script as much as we possibly can, because every client's kind of different as far as what specific components within R they want to use. Some people are okay just installing R via Yum, but a lot of people want to compile it and have specific compilation flags that they want to set. So that can definitely be a pretty manual intensive process. The scripts that we usually use are like, PDSH or, using SSH to parallelize whatever we need to do across the cluster to kind of blast it out, because we have to compile R on every specific node. We have to go through and install every single current package manually. So you're right, it is definitely a time-consuming process, especially going through upgrades as far as if you want to take advantage of new versions of R and things of that nature. So unfortunately, from an amazing automation perspective, I don't have any good answers for you. The only tools that we use are, like I said, usually PSH, try it out on a few nodes and then roll it out to the rest of them. But a lot of it is just scripting. It's kind of laborious, unfortunately. Yep. Great. Any other questions, folks? Yes.
Yeah, along the R product lines with all of the open source components, there's sort of get started with Apache and then move towards support. So can you just comment on where Revolution Analytics fits in and what the migration might be?
Sure. I think we definitely see a lot of people starting with the open source version of R. I think a lot of people can get quite a bit of mileage out of it. Once people start getting past, I think some of the performance issues that people run into, and depending on the specific libraries that they're using, a lot of people will start looking at Revolution Analytics and talking to them about their specific custom components. I know they have a lot of optimizations within the specific libraries, especially around mathematics, taking advantage of some of the Intel processor capabilities. So I think definitely it's kind of a continuum. I think a lot of people will start with the open source versions, they'll play around with it. It takes a while for people to kind of get a good understanding of how to use it well, and obviously how to take advantage of some of these capabilities to actually parallelize whatever they're trying to do. And that's when they start running into some of the performance issues, as you had mentioned, as far as constraining access to memory, making sure it doesn't trample over your entire cluster. So I would say usually when people look at Revolution Analytics, they understand the problem that they're trying to approach. They understand some of the limitations of the open source components for their use case, and they're looking to engage them for either additional support or additional capabilities to take advantage of better performance. Yes, sir.
Do you have examples, I guess, of types of analytics R and Hadoop can solve? So you gave a problem of like word counting, but how about like clustering techniques or regression? Is that solvable with R right now? Because that depends on the order in which data comes back in order to do that type of analysis.
Yeah, there are actually a lot of examples. If you look at the RMR package itself, if you can get the GitHub, one of my slide has the details on the GitHub repo, and that has a lot of examples. And another good way is to go through the test cases as well.
Yeah, but with that said, I think some of the more advanced analytics can be difficult to solve, especially clustering and things of that nature with RMR2. The onus is on you as the programmer, right, to be able to try to figure that out. Matrix multiplication, what kind of mathematics can you use essentially to make that happen? So it's definitely a great framework and a great tool to help you parallelize that, but there's a lot of work that you have to do yourself. Mm-hmm. Yes, ma'am.
So the announcement that was made between Revolution Analytics and Hortonworks in February, that ScaleR, which is a set of pre-parallelized algorithms, will be running in Hortonworks at the end of the year. So some of the do-it-yourself, building your own map and reduce will be taken away by that. So the algorithms will already be there for you to just deploy within Hortonworks.
Correct, yeah. I think we see a lot of people trying to take advantage of those packages because there's efficiencies, right? It's built in, it's fast. A lot of people will start with the open source, like we said, open source components just to get started, but there's a lot of efficiencies that can be driven by using those specific capabilities. Yep. I think there's a couple things. I mean, I think with Yarn, we're providing a larger generalized framework for resource management. So our hope with Yarn and the integration with R will be better resource management for the specific R jobs. Taking advantage of C groups, things of that nature to constrain the resource utilization of the specific R processes so they don't run all over all the other analytical workloads we have. So,
yeah, that's something that we can definitely do on using the Yarn side with the resource manager. Yeah.
Anything else? Great. Well, thank you very much.
Thank you.
I hope you found it useful. If you have any questions, please come up. I'd love to answer any questions. Thanks.
Yes.